This is Honors Algebra 2 Pre-Calculus. We're doing 10.7 in Pre-Calc, which is polar coordinates. In example 8, we're going to convert the polar equation to rectangular. We're only doing one in this example, so it's a little bit trickier, but let's walk through it. So remember, your entire job is to replace all the r's and the thetas with x and y stuff. So just like we saw in E7c, if you have a fraction and it's stressing you out, the best thing you can do is multiply this denominator over first. So you're going to have r times this 3 minus cosine theta equals a 5, and then you should distribute the r. So you're going to have a 3r minus r cosine theta equals 5. Well, that's great, because r cosine theta is a thing you know. So 3r minus the x, okay, I'm most of the way there. The only thing that makes this thing still polar is this. So right now I haven't converted at all. I've got this weird like mix and match thing. This was all polar, and now I have this weird mix of polar and not polar, which is kind of a hot mess. The easiest way to figure out what r is, right, the easiest way to solve this is that it's a lot better if I have an r squared. So what I'm going to do to make my life a little bit easier, because I can't really, so r could be a plus or minus. So I have two options here, okay, and I'm going to walk you through both. I think the better option is to get to the r and then square both sides so that I have an r squared. So to solve down to the r and square both sides. You don't have to do that. There is another way to do this, but I'm going to argue that's the better option. So I'm going to suggest that what you should do is move the x over to get x plus 5, right? And I wouldn't even divide by the 3 because I can square a 3r just fine. I'd get a 9r squared equals an x plus 5 quantity squared. And then I know enough to replace that r squared because that r squared is an x squared plus y squared. So my answer, if I do it this way, is going to look like this. 9x squared plus y squared equals an x plus 5 quantity squared, right? You can clean that up if you want. You can distribute. I don't care. You could make this a 9x squared plus a 9y squared equals an x squared plus 10x plus 25 for all I care, right? You could move the like terms over. I don't care. This is fine. This is fine. I would probably have stopped at this first answer. That's fine. The other option, and the reason I want to caution you about the other option is that you're going to have a plus or minus. So let's say you didn't want to do that, right? Let's say you said, hey, Hogan, I'm going to go right here, and I'm going to realize that since r squared is x squared plus y squared, r is plus or minus the square root of x squared plus y squared. That's fine, but you're going to end up with an awkward equation that has a plus or minus. It's not wrong, but that's what you're going to have. So you're going to have plus or minus 3 root x squared plus y squared equals an x plus 5. And that's also fine. It's just a little weird, and if you didn't have the plus or minus, I'd mark you wrong, right? So either of those options are fine. I think this is better. As long as you had the plus or minus, this option is right. If you only wrote this option as positive, I would mark it wrong.